Hey, it's Dan. This may be kind of a long video, but I'm going to try to squeeze everything into here. We're doing chemistry demos.
Oh, that's not what I wanted to do. There's just no way to just...
Still your right hand switch, the front ones. There we go. That's
All right. Well, welcome everybody. How lucky you are to be in the company of some great chemists. We're hopefully going to do some exciting things for you today. I think you'll find it pretty exciting. It's one of my favorite. I have two daughters that love this cat. So today, as I said, we're chemists, and we're going to be doing some fun demos to show you the wonders of chemistry and all the cool things that you can do if you study chemistry. First, I just kind of want to go around the room and kind of introduce all of the players in this play. First one, Dr. Jason Brinkley, Professor Brinkley, Professor Fay, and Professor Matt Sheets. I'm Dr. Cavagna. We're going to be doing the MC work here for a while. And scattered around here are a series of students. These are the ones that can tell you what it's really like to be in chemistry. And they volunteered to be here today all day doing this stuff because it's fun. It is fun. I know when we think about chemistry and science, everybody says, oh, that's so hard. It's so hard. It's math. Well, it's a little bit more than math. Chemistry is about how things interact. When you have two substances and they interact to make a third substance, that's chemistry. When you mix all kinds of ingredients for a cake, flour, sugar, butter, and you make a cake, that's chemistry. So it turns out that when you're doing chemistry, we kind of know the outcome of the cake, and we're not too worried for the most part. But sometimes surprises can happen. And in the last session, we actually had some of those. So in which case, we have to be ready for those surprises in chemical reactions. So in front of you somewhere, you should have a series of, or a set of safety glasses.
We got those in the last session.
You should have gotten in the last session. So we're going to ask that you put those on, because some of these demos could be a little dynamic. Right. So, and I just want to make sure I mention too, if you're sensitive to loud noises, you may want to put your finger in your ear, but some of these may be quite loud. We'll have some of them a little bright, but loudness and the noise is the most important thing. So Dr. Brinkley here is going to talk about, we're going to show us an example of what happens, what could happen if a reaction gets out of hand. In particular, what happens when you eat Pringles. Not really, but just so happens he's using a Pringles can.
And unfortunately, it did go awry last session, so I'm not sure if it's going to go right now. So be prepared for a really loud bang. Oh, good. It's going the right way. Hopefully.
But wait, there's more.
Unexpected, right? Unexpected, but cool. Right? That's why we started chemistry. So again, he had hydrogen gas in there. It combined with the oxygen in the air. It made water. Making water can be quite a loud event. I'm going to do something similar with a different compound called methanol. It's a type slightly loud. Probably close. If you prefer to step out, you can. But just be prepared. I don't want to make anybody do anything they don't want to do. But again, a similar reaction is happening in your car. Is there a way to shut the front light down? Okay. All right. So in that case, we were lucky that nothing really flew out at us. Ready? Surprise! So I'm just glad that Professor Fay didn't walk in. That would not have been good. So you can see sometimes sometimes things surprise us. In fact, you saw a little delay, right? You know, we thought, oh, nothing's going to happen. Let's just go home. And you turn around and it explodes. Well, we're going to talk. We're going to talk now. Dr. Brink is going to show us an example of what happens when you have a slow process that you want to speed up. And while he's setting that up, I'll just kind of talk about that a little bit. You know you can mix all the ingredients for a cake, but it's kind of pretty slow unless you put it in the oven. And if you raise that temperature a little bit, you get a little bit faster reaction. Well, there's things called catalysts that we can add to reactions to make them go faster. So the process is happening, but he's going to add a catalyst to make this happen.
Pink.
A pink catalyst, sorry, to make this reaction go. A sign of chemical reactions, a color change, bubbles, that means something's happening, like an alcohol. We can both of those now.
And look at the color. Now, if it's a real catalyst, it should be the same at the end. Look at what it's doing. Back to pink.
Just like the oven stays the oven at the end of the process, but all the other ingredients transform. Okay. Yeah. All right, I just want to do something really quick here. Can I give you a little background? What's that thing called? Periodic table. What? I heard somebody say the rest of it. Of the elements, right? What are the elements? Not big things with a long trunk, right? That's elephants. Those are hydrogen, helium, lithium, sodium. These are our basic alphabet. We put these together to form molecules. The molecules join to form, like words form sentences and so forth. We form bigger things, like Dr. Brunton did here. Are they just randomly put on the periodic table? We just throw them up there as we see fit? Well, they're obviously not in alphabetical order. Right? Somebody kind of got out of whack here with the A's, right? So it turns out that they're put on there for a reason. They're put on in groups because they all react similarly within one group. So that means that everything in column 1 does what a column 1 thing does. And it turns out column 1 elements are metals that really like water, sort of. They really like to interact and make stuff with water. So the first thing I'll show you is that, oops, sorry. Over here, these are metals. This is sodium up top here. This is sodium. Sodium is a very soft metal, and I hope I can show you this, in that I can pretty much just cut it in half just by squeezing it. It's very soft. I'm going to put my goggles on to make sure I'm safe. But it turns out that these metals react very strongly with water. So here's some water. I'm going to just put one of those in water just to show you what happens. That's sodium. You're dancing on the top there. It's producing hydrogen gas. If you can hear the sizzle, it's producing hydrogen gas. But something else interesting happens as you move down the periodic table. They react similarly. They look similar, like this guy over here, if you can kind of see this over here. I'll try to move faster here. This is potassium, which is in the same group. Very soft metal. You can see I just kind of broke it with the scupula. Like sodium, it tends to react strongly with water, with one little difference. So you can see the difference in reactivity. They're similar. Sodium with potassium created a little bit of a flame. Are you not going to?
Do the lights.
Okay. Next thing you know, by the way, the color change, I added a chemical to make it change colors. So it gave that a little extra cool chemistry boost. So it turns out, oh, I totally forgot that experiment.
So he's going to start that one.
Okay. So light is a very important part of chemistry. When we shine light on objects, we watch for sometimes how they respond. What are the three main components of an atom?
The neutron, Electron, protons.
Proton. Protons at the center, electrons, like a Ferris wheel sort of, kind of in 3 dimensions, kind of go around it. Those electrons are responsible for chemistry. And if we can excite those electrons, get them up on a shelf, like this, right? Excite them up by heating them up or mixing chemicals together. And when we let them jump down, they release light as energy. Depending on that step size, the color of light changes. He's going to show you what happens when you mix 2 chemicals and we excite those electrons and let them fall down. Oh, wait, sorry. This is mixing 2 chemicals. When they combine,
That is so cool.
very similar to what you see in glow sticks. You have to break the container to mix the components. Okay. So if you like things like Disney World and you think it'd be really cool to design rides and attractions, that's how they do it. They understand the chemistry of light a lot of times and how it interacts with matter. I skipped this, but this is a little bit more about how light is formed. It turns out that when you heat substances, as I said, you raise the electrons up and they drop down and they create light when they fall down. And come on. There we go. So what I have here, oh boy, I burnt myself. We have unexpected event. So we have some salts. These are different kinds of salts than table salt. This one contains a compound called lithium chloride. And in fact, it contains the element lithium. And when you put it into a fire, it creates a really cool red color. That red color tells me lithium is present. Other salts do this. Depending on what's there, they will change color. This is something called barium. And I hope I get enough here. But that's kind of a green color.
Barium, isn't that what you, when a chemist dies?
When a chemist dies, it's barium. Yes. Barium. So, we can't guarantee they're all going to be unexpected events. So that said, if you understand those kinds of things, you could design fireworks. You could shoot salts up into space and let them rain down hot and see a bunch of light that results. And I think, are you going to?
I was going to do it at the end. I'm going to do it at the end.
And you don't have.
I've got 2 that are behaving.
So Professor Fay is going to show you what happens when you shine really high energy light on an object. You raise an electron really high and let them roll down and produce different colors. Lights. So he's going to shine ultraviolet light, a very high energy light, on some objects and watch what happens. Oh, not working.
There we go. Okay, first of all, I'm in disguise. I'm not a chemist. I'm a geologist.
Oh.
But we still use chemistry anyway. All sciences need some stuff from the other sciences. So what happens with minerals, there's 100 and some elements, and they can be combined in over 4,000 different ways to make different minerals. The first one I got here is sulfur. It's an element all by itself, but a mineral too. And it's got that really neat yellow color. Now if we shine a black light on it to give it more ultraviolet light, give it higher energy, see if we can make those electrons jump and do something different. Well, they don't. They just do the same thing. Here's somebody else. This guy. Now this guy has several different minerals in there, and notice how colors we got. We got some white, we got some black, and there's some brown in there. That's regular light. But if we shine ultraviolet light, higher power, it's going to do something like this. So what was white to begin with goes pink, and the brown becomes green. Now only a few minerals know how to do that sort of thing. Only a few of them have the right kind of elements to do that. There's some biology here too. Some living things also exhibit this property, and Who's that?
Scorpion.
Scorpion, yeah. Scorpions do some cool stuff.
Is that real?
And it's real.
Oh my
What
God.
they doing? Okay, there's regular light. Just kinda. And there's ultraviolet light. So next time you're out in the desert, be sure to take an ultraviolet light with you because you can see these glowy green things at night in these scorpions.
Or in a Texas hotel.
Yeah.
Yes.
Frank?
Yes, are you ready?
Be ready. Yep.
Are you ready?
Yep.
Okay, so the next thing we're going to talk about here is, again, kind of going back to the energy that comes from reactions. When you eat food, you get energy, right? We talk about getting energy from our food. We have calories that we consume. Well, what's happening is when you metabolize that food, when your body digests it, it turns into energy, releases heat that drives reactions. And when you eat a gummy bear,
Go ahead and turn the lights down.
a lot of calories are released. Calories just means heat. And he's going to show you what happens, what kind of energy is produced when a gummy bear is metabolized.
Oh. I got a sticky gummy bear.
Great gummy bear today. What's going on in your body right now? All right, so I think that kind of brings us to the end of the show here, with one exception. I'm going to talk a little bit about making cakes and food. Food chemistry is a really important part of chemistry. So if you like the Disney World thing and the light, that's one aspect that could be fun. But food chemistry, there's people who design chocolate, right? All kinds of food. Ice cream. Well, it turns out that we have a specialist who's a chemist out there that would like to show you that process. So if you want to stand up and head out that way, Professor Lipton is going to show you a little bit about ice cream, how it's made. This one's ice cream. I'm going to give you a handout.
We also have takeaways.
Oh, you got kids coming right now?
Yep. Awesome. Ice cream going.
Squeeze by you.
All right, guys, come on through. Help yourself with some ice cream, and then hang around for just a minute.
We can come on through, guys. Come on.
We're making ice cream here. We're using liquid nitrogen to get it cold. So we're going to add a little liquid nitrogen here. Liquid nitrogen. Nitrogen is evaporating. You can see the liquid nitrogen evaporate. As it does, it has to get energy from somewhere, so it takes the energy out of the milk and the cream and the eggs, and it makes them freeze. So what you're eating is this mixture that I've made using liquid nitrogen to cool it, and I've got a hand mixer. I'm going to try and make it a little smoother, but it still gets a little chunky. And up there, looks like it's okay. Got a fresh batch coming here. And then while that cools down, you guys have seen how racquetballs bounce. Well, I've got a racquetball in some liquid nitrogen. I'm going to drop that racquetball over the edge, and I've got somebody, I've got a volunteer down there ready to get that. You can see how this bounces. And if you guys come over to the side, you might want to get over there. I'm going to drop a regular racket ball and I have it frozen first, and you can see what happens when that drops. Here comes the regular one. Bounces pretty well. Now, I'm going to flip hands here. I'm left-handed, so I'm going to go backwards with the ball. I have a better aim with that. We're going to take this and we're going to throw it out here. You guys ready? Here we go. All right, enjoy the ice cream and have a great next session.